Now, let us solve some problems related to Poisson distribution. The number of accidents in a year to taxi drivers in a city follows a Poisson distribution with the mean 3. We know that mean of the Poisson distribution is nothing but m, that is equal to 3. Out of 1000 taxi drivers, find approximately the number of drivers with no accidents in a year, more than 3 accidents in a year. So if you take x as a random variable as a number of accidents in a year, then no accidents in a year means p of 0, or you can use the notation as f also. Since they have taken f notation because p is nothing but a probability distribution. Now for probability for no accident at x equal to 0, out of 1000 taxi drivers they asked you to find. Hence multiply that probability condition with 1000. So you will get the number of drivers who in a year who has not met with an accident. So here number of drivers with no accident is f of 0. X is nothing but 0. So what is the formula? M to the power of x e to the power of minus m by x factorial. We know the m value. It is nothing but 3. So 1000 into 3 to the power of x e to the power of minus 3 divided by x factorial. Now the simplified answer you are getting it as 50 into 3 to the power of x by x factorial, and e to the power of minus 3 value and 1000 they have simplified it. If you don't simplify also, we'll do that simplification directly. You can do it using calculator. Now here f of 0 x 0 means substitute x as 0. You will get it as 3 to the power of 0, 0 factor equal to 50. Now they have asked you to find out more than 3 accidents in a year. So x is greater than or equal to, more than. So greater than 3. So greater than condition can be found easily with 1 minus probability of x less than or equal to 3. If I go to find out directly greater than 3 means x equal to 4, x equal to 5, x equal to 6, etc. till x equal to 10,000 I need to do it. So number of terms are x value is more. So instead of that, the easiest method for to do the calculation of probability of x greater than 3 is 1 minus p of x less than or equal to 3. This equal condition should include in any one of the side. It means in greater it is greater than 3 they are, so it should be greater only. I can't take equal sign. So that equal sign should be taken here in less than or equal to 3. So what you will get? P of 0, P of 1 plus P of 2 plus P of 3. So apply Poisson distribution formula and directly simplify it. You will get 0.35. So multiply that answer with 1000. You will get 350 drivers will meet with more than 3 accidents in a year. Now, in this problem, in the question, they mentioned it follows a Poisson distribution. So directly we applied the Poisson distribution formula and found the asked conditions. If Poisson distribution word is not applied in this problem, then which distribution should be applied? We will be in confusion. Is it binomial or Poisson? How we can find out? Always Poisson distribution will be applied when n is very large and p is probability of chances is very small. Probability chances is very small. It means for the rare cases. Rare cases means what? So many people drive, but accidents happens with less chances. So the chances of getting probability of meeting a accident is rare cases. And observe that the out of the n value, how much they asked? 1000. So it is preferably to apply Poisson distribution than binomial distribution. Okay. Let me take one more example. Here, if the probability of bad reaction from a certain injection is 0.001, determine the chances that out of 2000 individuals, more than 2 will get a bad reaction. Now here you have to decide in an exam, if this question is come, you need to decide which distribution should be applied. Is it binomial or Poisson? How we decide? We need to apply for Poisson. Observe that n value, there is no other n value, yes or no, in the given question. N is 2000 individuals. So 2000 is n value is very large. And bad reaction is of very rare cases. Yes or no? So many of us we take an injection, but getting infected with some injection are the rare cases. So here observe that probability, the rare cases, how you can decide also with 0.001. So p value is very less. You can observe in the binomial distribution problems where we have taken p value as 0.5, 0.1. So where p is larger than this. So when p is very small, n is very large, we need to apply Poisson distribution. So for the calculation purpose, to get the more accurate answer with this distribution will be possible than the binomial distribution. So here if I take a x as a number of people, individuals getting a bad reaction with a certain injection. So x they asked you to find more than 2 will get. So x should be greater than 2. So greater than 2 condition can be found with 1 minus p of x is less than or equal to 2. So p of x equal to 0, p of x equal to 1, p of x equal to 2. So you need to substitute this probability distribution in the formula of Poisson distribution. What is the formula? M to the power of x e to the power of minus x divided by x factorial. Here p is given, n is given. They are not given the m value. And we know that m is nothing but mean. As one of the conditions for Poisson distribution is always Poisson distribution is a limiting case of the binomial distribution. Hence, mean of the Poisson distribution is m, which is nothing but always n into p. Since Poisson distribution is a limiting case of the binomial distribution, it means the Poisson distribution is derived from the binomial distribution itself. So apply n into p value, you are getting the m value. Substitute the m value and simplify, you will get probability of x greater than 2. Do this simplification using calculator directly. Fix it to 4 decimal places and do the calculation. You get the required answer. Let me take it one more problem to make you to get familiar with the rare cases. See here the question is probability that a news reader commits no mistakes in a reading. The news is 1 by EQ. So here probability P is given as e to the power of probability of news readers will not commit any mistake, no mistakes. So x equal to 0 they have given it as e to the power of minus 3. So when I substitute x equal to 0 here in the probability distribution, what I will get? M to the power of 0, e to the power of minus m, 0 factorial. So it will get simplified to e to the power of minus m. So e to the power of minus m equal to e to the power of minus 3. compare the LHS and RHS, you will get m value equal to 3. Observe that in the first problem where m is given directly, in the second problem where m is found with the formula n into p. Now in the third problem where m value we obtained from the given condition. What is the condition? Probability of newsreader not committing any mistake, that is x equal to 0. Probability of x equal to 0 in the probability distribution formula we substituted, and they have given the probability of that as e to the power of minus 3. So comparing the LHS and RHS, we obtained m value as 3. Now using this data, they asked you to find out the probability that on a particular news broadcast he commits only 2 mistakes, more than 3 mistakes, at most 3 mistakes. Only 2 mistakes means x equal to 2. More than 3 mistakes is nothing but x is greater than 3. How to simplify greater than 3 is 1 minus p of x is less than or equal to 3. At most 3 mistakes. It means he can do at most 3 mistakes, not more than that. So it should be probability of x is less than or equal to 3. So greater than 3, probability of committing at most 3 mistakes means x is less than or equal to 3. Here in the bracket value what you obtained it. This itself if you simplify, you get the answer 0.6472. Okay. Now next, one more problem. We have studied it fit a binomial distribution in the last class. Here also they asked you to find out a Poisson distribution. From certain table is given, some data they have given. Now here we need to obtain a Poisson distribution for this theoretical frequencies what they have given. Now the question is, I need to apply Poisson distribution. I need m value, that is nothing but mean. So mean value we can find it if n is there and probability p is there. But with this given frequencies we can't find out. And there is no chance of finding it out the probability directly from the given data. So in that case, we use a statistical method of finding the mean of the given data in a table value. What it is? In a statistics we studied that mean is nothing but summation f into x divided by summation of f. It means f and x multiply, these two values you multiply, plus these two values you multiply. See here, 122 into 0 is 0, 60 into 1 is 60, 15 into 2 is 30. Summation stands for adding all those values. Similarly, 3 into 2 6, 4 into 1 is 4, divided by summation of f value. 122 plus 60 plus 15 plus 2 plus 1 gives us 200. So what you will get mean value as 0.5. So in case we don't have any other method of finding it in the given data, for mean you use statistical method to find out the mean value. So here p of x is nothing but m to the power of x e to the power of minus m by x factorial. And we know that to calculate the probability distribution from the theoretical frequency, how much frequency is used, that we need to multiply. So 200 into p of x. So 200 into probability of x equal to 0. This value you need to. So substitute it in the Poisson distribution formula. Simplify. Here they have simplified with only m value. Then they have taken x as 0, 1, 2, 3 and obtain the required theoretical frequencies as 121. Actually observed is 122. Theoretically we obtained 121. observed value is 60. Theoretically we obtain 61. So and observed and theoretical frequency value, here it is same 15. And here it is 2, here it is 3, last one is 1. Theoretically what we obtain the distributed value of frequency is 0. So here main thing is new concept what we applied is using statistics we are finding the statistical concept, we are finding the mean value. So solve these 4 problems, take this itself as an assignment and submit it all these 4 problems in a classroom as PDF form. Thank you.